In this video, we're going to discuss the inverse of a function. It's going to be very important as we discuss the inverses of functions that in the original function you understand what we're inputting and what we're outputting. Because with the inverse, what we're going to do is create a new function where we put in the output from the old one and we'll get out the input from the old one. So here's the idea. If y equals f of t, we are inputting a t and outputting a y. In the inverse function, you're going to put in that same y value and you're going to get out of it the corresponding t, the input that would have gone with it in the original function. So for example, if y equals f of 7 equals 8, then what that means is we inputted 7 and we outputted 8. So in the inverse function, f inverse of y equals t. When y is 8, t is 7. So f inverse of 8 would be 7. When we put the original output of 8 in, we'll get out the input of 7. Let's talk about how this applies to real-world problems. It's important to recognize from the original function what the input was and what the output was so that we can associate it to the inverse. So let's look at this application. If C equals F of K gives the cost of using K kilowatt hours, then what would F inverse of C tell you? So let's consider the original. In the original function, the input is K, which is kilowatt hours, and the output is C, which is cost in dollars. So in the original function, we're getting out a cost in dollars when we put in kilowatt hours. That means in the inverse function, we're going to get out a number of kilowatt hours for a certain cost. So the inverse, notice how there we'd be putting in a C. We would actually get out a K. So the inverse is going to tell us the number of kilowatt hours we can use for a cost in dollars. We would put in the cost in dollars and we'd get out the number of kilowatt hours. So let's look at the one below. If F equals G of T gives the number of foxes in a population after T years, then what would G inverse of F tell you? So in the original, we're getting a number of foxes when we put in a number of years. That means G inverse of F is going to give us a T. That is to say, the inverse will tell you the number of years it has been for a certain number of foxes. So let's talk about how to actually find the inverse. how we do this algebraically. First, I want to recall the inverse of a function. So here, f inverse of y would be t. We want to swap the output and the input. We're going to put in y and get out a t. Notice how the inverse is t. The inverse is t. It equals t. So what we're going to do is solve the original function for the input value. So let's solve the equation. We don't need f of t because we're going to use inverse notation. So let's solve y equals 6t plus 9 for t. And again, the reason we're doing that is t is the inverse. T equals the inverse. So if I want to solve this for t, we need to get everything on the opposite side of the equals except for t. So let's move 9 over by subtracting it. Y minus 9 equals 6t. And then to undo multiplication, we use division, so we're going to divide everything by 6. T equals y minus 9 over 6. Notice again, t is equal to the inverse. T is the inverse. So I'm just going to swap this notation out and say that f inverse of y is equal to y minus 9 over 6. That is the inverse function. Notice how the variable in the inverse function is y. Y is what we're putting in. So let's take those two ideas and put them together and see exactly how they're related. So the cost in dollars of producing our refrigerators is C equals some function of the number of refrigerators equals 1,250 plus 50R. So in the original function, we're getting the cost for a given number of refrigerators. We know G inverse of C, we're now putting in a cost and we're getting out a number of refrigerators. So this will tell us the number of refrigerators we can produce for a certain cost. To find the inverse, we know G inverse of C. G inverse of C again equals R. So what we're going to do is take the fact that C equals 1,250 plus 50R, and we're going to solve this for R because R is the inverse. R equals the inverse. So solving this for R, we would subtract 1,250 over. And then divide everything by 50. So R equals C minus 1,250 over 50. Remember, R is the same thing as the inverse. This thing is the inverse. So G inverse of C equals C minus 1,250 over 50. What this would allow us to do is put in a certain cost, plug in cost, and get out a number of refrigerators that's associated with that cost.